Practical Unit 3 Flame Photometry. And flame photometry, this is what is the flame test which we used to do in FYBSc. From the color of the flame, we used to identify the elements present. So I'll start the video. One minute. So this is what is so this madam is going to show us the flame test. See, she has taken all the salt, metallic salt solution, and they are in chloride form. Calcium chloride, copper, lithium, potassium, sodium, and strontium chloride. Right? So now from the color of the flame, we can identify whether calcium is there, copper, and you can see the color of the flame also. So let's see. And see, in the lab, you should be with the lab coat. You should be with the safety goggles. We miss our lab. Hope the pandemic gets over and we start. Yes, so I will just go. Let's go to the main part. He has taken here. We have taken the aqueous solution of the metallic salts, alkali and alkaline earth metals. Right. So this is a burner and she will be taking this and aspirating the metallic salt solution in on the burner, and let's see the color of the flame. Last lecture we had seen all the detail about this, so I am running it. Oh my god, someone has come. Who is it? Should I stop 1 minute? इधर wait. कौन आले आता? 1 minute. Someone has come. कौन है? Amo. Where were we were here, right? Hmm. Yes. So you can see the colors. She's explaining how we take the salt solution, how to hold it in the flame. Always you will hold it at the tip of the flame. Now see, someone else has come. I have to take him in. Please come on time. Okay. So always you should keep at the tip of the flame. This is a Bunsen burner. Yeah, now first salt, calcium, orange red color. This color, if you get, see, orange red, bright orange red color, if you give, you will report, yes, madam, calcium is present. So the color of the flame is used to identify the elements present. Next is beautiful copper bluish green. See the beautiful color of bluish green. And this we have done it in FIBSC. Many of y'all used to get the color. Then comes your lithium. Yes, you can see bright red color. This is the color of lithium salt, not necessarily chloride. Sulfate hoega to be, you will get the same color. Then comes potassium. Now wait. See, potassium is color is very potassium color, it is very difficult to identify. You can see you get a pinkish violet color along the border of the flame. So most of y'all miss this color. But this y'all will learn only with practice. This color is of potassium ion. Yeah, beautiful pinkish violet, faint pinkish violet. Pinkish red, sorry, it is pinkish red, or you can write pinkish violet. Next is sodium, golden yellow color. See, yes, if you get such type of color, you will report sodium is present. Then you come to strontium red, bright red, crimson red. This color is called as the crimson red color. If you get crimson red color, you will report strontium present. So what happens is, where is my PT now? Wait. No. I'm sorry. I'm sorry. So what happens is, where is not this, not this one. Yes. So what happens is, depending upon the color of the flame, you will come to know whether calcium, copper, potassium is present. And this technique was further developed to develop an instrumental technique called as flame photometry. So what happens now? Suppose one more thing. In flame test, you used to find the color, and then you always confused. Madam, it is orange red. Sometimes you would say, Madam, it is reddish crimson red. So instead of that, what we do is, here is the visible region of the spectrum. We always study in our nursery class violet, indigo, blue and green, yellow, orange, red. So this is the colors of the visible spectrum. If the instrument shows wavelength 400, means it is pinkish violet. अगर एक कंपाउंड ब्लूइश ग्रीन दे रहा है कॉपर मीन्स इट इज emitting light of 500 nanometers. If it is giving apple green, it is 550 nanometers. So instead of getting confused with the color, the technique flame photometer will display the wavelength. So you need not get confused, madam. I had got orange red, and I will say no, it was crimson red. Instead, if the instrument displaces 600 nanometers, you can easily report calcium present. अगर 650 के ऊपर है तो you will report strontium present. अगर if you use this instrument flame photometer, right? So in short, with flame photometer, you will get the wavelength of emitted radiation. मतलब violet color emit किया तो it will show 400 nanometers. अगर apple green, if barium is there, it will emit in 500 nanometer. No need to struggle with this colors. अरे it is apple green, it is orange, it is golden, yellow. So with the flame photometric technique, you will directly get the wavelength of emitted radiation. So that is a technique of flame photometry. So now let's see what is the principle of flame photometer method. This is always asked for 5 marks. Okay, mostly it is asked. Discuss the principle of flame photometer. So let's see what is the principle of flame photometer. Okay, so now I'll explain with my board. Yes, yes. So what is flame photometry principle? Most important. There are many objective questions from principle, and if it is offline, you will have to write principle for 5 marks. What will you write? You have to be very careful while using the words. You will write when the metallic salt solution is aspirated into the flame, means when you spray it into the flame, what will happen? First, vaporization will take place, atomization and excitation. So now let's see in a tabular form. This is a metallic salt solution which you have prepared. We have seen it in the video. You can dissolve it in HCl But there, in the video, she had taken all chloride forms. Therefore, those solutions were made in aqueous solution. Otherwise, in our lab, we add HCl and then you spray aspirate. मतलब क्या? You spray it in, convert it into spray. So you will get fine drops or you will get mist of the salt solution. This in the flame undergoes evaporation. Evaporation मतलब क्या है? Solvent vaporizes. Solvent vaporize होने के बाद you will get a solid. See the liquid introduced here, right? So your vaporization say you will get a solid particles of the salt. This solid particle undergoes vaporization and you will get the vapors of the salt. Afterwards, in the flame only, these vapors undergo atomization, means atoms in the gaseous state are formed. I have shown M plus gas, X minus gas. These cations will absorb thermal energy from the flame and will get excited. These excited atoms are short-lived and they will emit characteristic radiation and come to the ground state. Characteristic radiation means copper star will always give bluish green color. Calcium will give orange red color. So it will come to the ground state by emitting characteristic radiation and we measure this emitted color, light color, photon. So emitted radiation is proportional to number of excited atoms. मतलब ज़्यादा strong होगा तो number of excited atoms are more. So principle, if you write up to here, you will get 2 marks. Mumbai University, 100% students will attempt up to here 2 marks. Then next, emitted radiation is proportional to number of excited atoms. जितना कैल्शियम है उतना ही bright color आएगा. This is one point. Next, if E2 and E1 is the energy of the excited and the ground state atoms, E2 minus E1 is equal to H mu. But we know mu is equal to C upon lambda. Therefore, we get lambda is equal to, either mu is equal to C upon lambda, take lambda over here, lambda is equal to HC upon E2 minus E1. Don't leave it up to here. What is the significance of this equation? You will write lambda will help in identification of elements present. We have seen if wavelength of emitted radiation is 400 nanometer, you will say potassium is present. 550 के ऊपर होएगा तो क्या है? करीब reddish color है, strontium present. So emitted wavelength of emitted radiation helps in identification of elements present. If you write up to here, you will get total 3 marks. 2 marks over here, 1 mark over here. Next, this is not the end. Next part we come to after this. You will write the fraction of excited atom n star upon n0 is equal to A e raised to minus delta E upon kT. And this equation is called as Boltzmann's distribution rate equation. Okay, so it is called as Boltzmann distribution equation. And then you will write very nicely n star is equal to number of excited atoms, n0 number of atoms originally present, A constant, delta E energy before and after, and then you have K is a Boltzmann constant and T is a temperature in Kelvin. This is what you are expected to write. Okay, and then this is also not the end. इसके बाद ये सब क्या है? You have to write. Therefore, number of excited atoms depends on depends on two variables, delta E and K, because all the other factors are constant. Depends on delta E and temperature. If you increase the temperature, this will decrease and number of excited atoms will be more. The one who writes from this point to the last statement will get full 5 marks. What students do, most of them will end over here, but few average students will go up to lambda. What is lambda? But they will not write the statement. Lambda is used for identification of elements. Lambda मतलब क्या है? I showed you the wavelength range, visible region, violet, indigo, blue, and green. So depending upon the wavelength, you will identify the elements. Then quantification is given by Boltzmann's distribution equation. And this equation is very, very, very important. Are you all there, Vignesh? Are you there? I can't believe Vignesh.
Yes, ma'am.
Yes. Okay. Now listen. All students listen. Objective question. From this, what they will ask is gas serves for identification of elements in flame photometer. You will write wavelength of emitted radiation. Next, they will ask n star upon n is equal to dash. Okay. Third objective question. They will give you this equation and they will ask what is A. A stands for dash. What is K? What is T? Anything. This equation is very, very important. Or they may ask flame photometer is governed by dash equation. You have to write Boltzmann distribution equation, right? And they may ask the sequence of events taking place. Select the correct sequence. So ये थोड़ा jumble up करेंगे and they will ask you to select the correct statement. And till now, if you have identified this is an elemental analysis technique. Now tell me, any difficulty till now, you can put in the chat box. And otherwise, we will go ahead with the burner part. Any difficulty? Who is it? Saurabh? Any difficulty?
मैम
Yes, yes. Pooja, go. Tell me.
मैम वो एंड एंड डैश अपॉन एंड नॉट इज इक्वल टू ए ई रेज टू मैम क्या है
ई इज वो लॉगरिथम वाला ई है ना, वो है. Got it, Pooja?
नो मिस
A, E, छोटा E you are asking, right?
हाँ मैम ए ई
That,
रेज
you are asking about the small e. Small e is a log constant. If you have studied in your logarithm in 12th
यस
standard,
मैम
so उधर वो e है ना, that serves as a log factor. If you
यस
want, I will send a detailed derivation part to you. You read it, you will get to know what is E over there. It is a mathematical constant, okay, related to log. Right, Pooja? I will send it to you. Huh, Pooja? Are you
ओके
a
मिस
PCM student or CPZ?
मैम पीसीएम
Ah, right. So you will understand it. I will send it to
Yes.
you. Right? Very good. Anyone with any questions?
Ma'am,
Anyone
can you
else?
explain Boltzmann?
Yeah. Boltzmann distribution ratio is wait. Yes. Once again, I will write fresh. What is Boltzmann is n star upon n0 is equal to a e raised to minus delta e upon kt. So what is n? N is number of excited atoms, and this is the number of atoms originally present in the flame. So this full fraction becomes fraction of excited atoms, fraction of excited atoms. And we are interested in how many atoms are excited. Why? Because then only you will come to know how much of calcium is present in your solution. And here you have A is a constant, E is a mathematical constant, delta E is what? E2 minus E1, energy of the atoms in the excited state. E1 is the energy of the atom originally present. See, atoms flame में डालेगा तो उसका एनर्जी बढ़ेगा. So once उसका एनर्जी बढ़ेगा, it will go in excited state, and these excited state atoms are short lived and they will come back to the original state by emitting radiation. So energy of emitted radiation is E2 minus E1. Again you have K is a constant which is equal to R upon N, and then you have T is the temperature in Kelvin, and this is the number of excited atoms which are originally present. Is it clear, Saima?
Yes, ma'am.
Okay. So this fraction of excited atom will tell you how much of calcium was there. More excited atom, more strong flame you will get. And then you will measure intensity of emitted radiation. And from that you will come to know, अरे calcium इतना है ppm. You can say strontium is so much ppm. ppm you can convert into molar. Okay, fine. See, this principle is very easy and very nicely given in your textbook, which I had referred. So now what we will do is we will go ahead with instrumentation. Right? Anyone else, boys? Do you have any doubt? Rishikesh, no, Gaurav, Avdut, anyone?
No, ma'am.
Okay, so
No,
now
ma'am.
it is very, very, very important technique. See, now we will go to the instrumentation part. Okay, so I share my screen and I have to go over here, I suppose. Yes, is my screen visible to all? So principal you
Yes, ma'am.
yes, principal you have to write everything new lambda. Lambda is equal to this wavelength of emitted radiation, intensity, amount of, then Boltzmann distribution equation. Very nicely you write. And the one who writes the last line up to here gets full mark. Okay, so in NL it is easy to get above 90 if you study properly. Now we go to the next very, very important part, that is your instrumentation. So what happens in instrumentation? The first component is your burner. Now let me see. We have 10 minutes and I have to show you one video also, right? So let's see if I can complete. So this is a full component schematic diagram of a flame photometer. Components of a flame photometer. This is a schematic diagram, right? So the first component is your burner. Very, very important. Yeah. So the burners are of two types. This is one total consumption burner, and then we have a pre-mix burner. Total consumption burner. Wait, I just go fast over here. What is the role of burner? जब हम salt solution बर्नर पे डालते हैं तो क्या होता है? फर्स्ट ऑब्वियसली द solvent will vaporize. After the solvent vaporizes, it gets converted into atoms. And then the atoms absorb thermal energy, excite to the burner, should vaporize the solvent, it should atomize your salt, and it should cause excitation of the atoms. So this is the role of burners. So in exam, some short questions are definitely asked. What is the role of burner in flame photometer? You should be able to write. बर्नर क्या करता है? सॉल्वेंट को निकालता है, एटम्स फॉर्म होता है, एटम्स के बाद दे विल absorb energy from the flame and get excited. This we will come later on, temperature of the flame. The first burner uses a total consumption burner. You can see either marker. Where do I get marker? I'm not able to place. Anyway, can you see my cursor moving on the slide?
Yes,
Yes,
ma'am.
ma'am.
Okay, okay. So what happens? This burner, total consumption burner, it consists of three tubes. One is a center tube and two sides tubes. Through the center tube, the sample is sucked into the flame, right? And there is a nebulizer. Nebulizer क्या करता है? वो sample को spray में convert करता है. I will show the video of that. So the sample is sucked into the flame through the center tube. The nebulizer attached at the base of the flame will convert it into the fine spray. And then the fuel, that is hydrogen, will enter from one side tube and oxygen, that is oxygen, will enter through the second tube. This is the fuel which will produce the flame, whereas oxygen is as your matchbox, right? So this is a total consumption burner. I'll show you one video. Wait, wait. I have removed today morning. किधर गया? Yeah. Very nice video I got for this. I can say. Oh my God, where am I? Yeah. 1 minute. Yeah. So you can see 1 minute. This is a part. See, this is the gas. Now, उधर hydrogen लिखा है, but we use our cylinder, gas cylinder, LPG cylinder. So this knob she is rotating to adjust the gas flow pressure. This knob will show the pressure 0.8 को adjust करता है. That means they are adjusting the flow of air. You know, we saw air is used as an oxygen. So this air flow is adjusted by this knob. And then you have a nebulizer. See, you will be able to see the nebulizer. Why is it not moving? Yes, yes, right. Huh. See, your sample solution will go through the center, and yeah, it is aspirated in the form of a spray. See, because of the nebulizer, this rod is a nebulizer. So the sample is sucked from this tube, and the nebulizer will convert it into fine mist. Spray matlab mist, fine droplet, and then it is introduced into the flame. अभी क्या होगा फ्लेम में? What they are showing over here. Should I go ahead? Wait. Sorry. Wait. So the sample it will go through the center tube. Here there is a burner, gas burner. See, they will show you now. I think we went ahead. On, power is on. Now, this is your like your lighter. This will light the burner automatically once you keep it on. See, this is the burner in your flame photometer pre-mix burner. So sample gas is on now, flame is on, it shows power on, flame on, right? And then yeah, sometimes this is a safety hood. You can see the flame from, yeah. This is device we have when we lit the burner with a matchstick in our lab. The previous model was auto lighter. Here we lit it with a matchstick, and that's the pinkish violet. If you aspirate potassium sulfate or potassium chloride, you will get pinkish violet color, and wavelength displayed will be 450. Similarly, see, this is orange red calcium. No need to look at the color of the flame. You only see the wavelength कितना डिस्प्ले हो रहा है, बस you will come right calcium present. Yes, this is what it is. And आगे उन्होंने क्या दिखाया है? This is a safety chimney sort of thing hood. This is calcium, sodium, potassium, and calcium model. We can identify only sodium, potassium, calcium. Yeah. What they did here was, wavelength was adjusted to sodium. Wait. Yes, wait. Wavelength sodium पे adjust किया ना, so what happens? Only the golden yellow flame will fall on the detector. That I will explain it in my next lecture. Okay, excess of solvent passes into the trap. How it happens? 1 minute. Where am I? Where am I? My God, I'm lost. 1 minute. Hmm. Yeah. Yes. So, any doubt up till here? Next part we will continue in our next lecture. We will again see the detail of a pre-mix burner.